Hi. This video is about some examples of balanced and unbalanced forces. So I've got two questions that I want to ask you, and I've got some situations drawn here. The two questions are, number one, are the forces balanced or unbalanced in this situation? And then question two, is it speeding up, slowing down, or moving with constant velocity? So let's look at our first example, example a hailstone moving down. We're given the free body diagram to show the forces that are acting on the hailstone. And this is important because we want to compare the forces and see if there would be a leftover force here. So we have gravity pulling down on the hailstone and the air resistance pushing up against the hailstone's motion. Because the gravity is stronger and bigger than the air resistance, we know that there is going to be a leftover net force here, an unbalanced force. So we say to the first question, the forces are unbalanced. There is a net force, and that net force is directed downward. The leftover force is downward. So next question, is it speeding up, slowing down, or moving with constant velocity? So it's moving down, and the net force is also down. So it's being pushed more down as it falls down. And so we can say, well, it's moving down and the net force is down, so it's speeding up. A way of thinking about this is it's being pushed in the same direction that it's moving in, and so it's just going to get faster. So it's falling down, and the net force is also down, so it's getting pushed more and more down, speeding up. Example B, we have a car moving to the right. Now, that could mean a lot of things, but in this case, we have our free body diagram with the forces of gravity pulling down on the car, normal, the road is exerting a force upward against gravity and balancing it out, and friction is acting to the left here. It says the car is moving to the right. So first question, are the forces balanced or unbalanced? If you're looking at the free body diagram here, hopefully you see if you add up these three forces, you're going to have a leftover force. The gravity and the normal, of course, balance each other out, but the leftover force is friction. There's nothing balancing friction. And so that means that the forces are unbalanced. We have a net force to the left. Second question, is it speeding up, slowing down, or moving with constant velocity? So we see that it's moving to the right. The car is moving to the right, but there's a net force to the left. So it's moving to the right, but it's being pushed leftward. And so because of that, we say that it's slowing down. Moving to the right and a net force / acceleration to the left means it's slowing down. It's being pushed in the opposite direction of its motion. All right, third example. So you have a desk being pushed to the right. So in this case, we have, again, normal and gravity. Friction is acting against your push, and then your push is to the right. If you look at all these forces, it appears that the gravity and normal are equal, and the friction and applied are equal in magnitude. And so therefore, all the forces appear to balance out. There is no leftover force. And so because of that, then our answer to the second question is automatic. If there is no net force, there can be no acceleration. So therefore, the object must be moving at a constant velocity. All right, let's do two more examples like these. But in this case, I'm not going to give you a free body diagram. Instead, I want to give you some different ways of representing motion. First is a dot diagram. So I do tell you that this object is moving to the right. That's important because we see that it's starting out with quite a bit of speed here, but then another second passes and it doesn't move as far. Another second, and it moves even less and less and less. So this object appears to be slowing down. Now, if it appears to be slowing down, then that must mean there is an acceleration, right? And if there's an acceleration, that must also mean that there's an unbalanced force. Objects don't naturally accelerate. They need a net force. They need an unbalanced force acting. So that helps us answer the first question. Are the forces balanced or unbalanced? Well, if it's slowing down, that must mean that the forces are unbalanced. There is an acceleration present here, and that means that the forces are unbalanced. There is a net force. We already answered the second question. It is slowing down. All right. Now for example E here, we have a time and velocity chart or table, and it tells us how fast an object is moving at different times. So at time 0, it's not moving. After 1 second, object is moving with a velocity of negative 10 meters per second. 2 seconds, negative 20. 3 seconds, negative 30 meters per second. So, are the forces balanced or unbalanced here? Again, you have to think about what that means. Balanced means that all the forces even out, there's no acceleration, no change in velocity. Unbalanced would mean that the object is possibly speeding up or slowing down, somehow changing its velocity because you have some leftover amount of force. Here it does appear that the velocity is changing, so therefore the forces are unbalanced. And in this case, the velocity is getting faster, speeding up in the negative direction. So those are some of the examples that you might run into as you think about free body diagrams and unbalanced and balanced forces. So that's all I've got for you in this video. Remember, happiness is not having what you want, it's wanting what you have.